Hey guys, I'm going to walk you through the process for doing the take-home coefficient of friction lab, in which you're going to be sliding different kinds of objects down various surfaces. So the basic diagram given to you in your handout is this one right here. The idea being you are going to have like a plank of wood or a piece of stiff cardboard or something like that, and then some kind of an object that you're going to be sliding down it. And it doesn't matter what it is, and it doesn't have to be shaped like this. It can't roll, would be the only restriction here. It's got to be something that's going to slide. So that means it could be, say, like a book. I don't care if it's a paperback or a hardcover or whatever, just got to be able to slide. Or maybe you're going to find another chunk of wood, or really it could be anything at all. Okay, you could use Lego bricks. It really doesn't matter as long as it's not going to roll. Okay, and it slides down at some reasonable, measurable angle. So the way that you're going to determine the angle is based on knowing the length of your piece of wood or cardboard or whatever it is, and measuring the height at which this begins to slide. Now, this is something that you might have to measure a couple of times because, as you will probably notice, it's a little bit finicky, right? Sometimes you'll lift it up to the angle and you swear it's the same and it goes immediately, or it goes before that, or maybe a little bit after it. Depends kind of actually how much you're jerking the thing up and down. So go nice and slowly, be patient with it, and you'll measure it a couple of times. Okay, since this is the opposite side and the hypotenuse, the angle then is going to be based on the sine function. So you'll be able to calculate that maximum angle using the inverse sine of whatever you measure h and L to be. Now, in a later part of the handout, you're going to be using the angle to determine the coefficient of friction. So there's a derivation that you're going to do where you determine that mu equals tan of theta. Okay, I'm not going to prove that to you right now. You will prove that in the handout for the lab. But based on the value of theta, you'll be able to determine the value of the coefficient of friction. Just to make sure that you're getting reasonable answers, the coefficient of friction for almost any material you pick is going to be less than 1. Unless it's some like outrageous rubber material, it's probably going to be less than 1. So you could use rubber, like if you've got a stapler with a rubber bottom, that's fine. But if it's like NASCAR tires, then you might get a higher number, like say 4. All right, let me actually show you what this is going to look like practically. So we'll act it out before your very eyes. All right, so here I have a couple of different things that are suitable planks that you could slide something down. So probably you want a shorter one. Although it doesn't necessarily matter that much, mostly just because if you're using a longer plank, you might have to tip it up an unreasonably high amount. And unless you've got one of these lying around, it's going to be a harder thing to measure. You don't really want to be fussing around with a flexible tape measure because it's going to like collapse on you while you're trying to measure the height. So something stiff like a ruler is good. And if you're using a shorter plank like this, you probably don't need anything more than a ruler. Okay, now, first thing you need to measure, of course, is the length of the plank. So here I go. This one. Now this one is stupidly cut. I'm sure everybody can see that this is not square at all. Okay, that will make my measurements a little bit more difficult, all right? So I would, in an ideal world, have chosen something with a square end, but I didn't have anything like that available and didn't really feel like whipping out the saw. So I'll just give you a measurement of some kind. Okay, it's 56 centimeters. You could actually probably use inches and it would be okay. What you can't do is measure like this side in inches and then measure the height at which the thing starts sliding in centimeters or vice versa. Okay, so you got to make sure you're measuring in the same units, whatever you're using. Odds are pretty good since we live in an English units country. You're going to have a inches measuring device. Okay, so just make sure that you're using, say, inches and inches or centimeters and centimeters, and everything should be fine. Okay, so if I'm using centimeters, we said this is 56. Great. All right, now I'm going to put a block of wood on there to start with. Okay, so I begin raising this with my measuring device handy with the 0 end pointed down, so I'm not doing anything stupid like measuring from 36 inches or whatever. Okay, keep raising it, oh, there. That right there seems to be the critical angle at which it begins to slide. So I'm looking at the end of the board being 21 centimeters above the table. Okay? If I get down and look a little more precisely, it's 21.5 centimeters above it. Now, I'm measuring from the table to the bottom edge of the board. Okay? Don't measure to the top, measure to the bottom. Reason being, this would be a height of 0, right? The bottom of the board is on the top of the table, so you're measuring from the tabletop to the bottom of the board. All right, next object. I'm going to pick a different piece of wood, and then I would repeat that, and then I pick some other kind of an object. All right, whatever. We said many different materials will work, but part of the purpose of the lab is I want you to be able to see that similar materials have similar coefficients of friction. So my 2 blocks of wood, if I raise them up, should start sliding at just about exactly the same position because they're both made of wood and they're both on the same surface. Okay. On the other hand, I would expect that the book will begin to slide at a different angle of inclination. Just find out what it is. Oh, that started going at only about 18.5 centimeters. And so when I do my calculation, I'm going to get a lower coefficient of friction for this smooth paperback than I have for this slightly rough wood surface. Okay, I think that should be everything that you need to see as far as how to set up the lab. So I hope that visual guide simplifies your laboratory activity. Let me know if you have any questions. Thanks.